Hi, Mr. Q. This is my Unit 3 curve sketching evaluation. And this is the video pretty much explaining how I got my work done, how I did my 10 steps, and how I graphed my function. So I picked the function f at x equals x squared plus 4x plus 8 divided by x squared minus 4. Right? I basically just thought of a function and worked it out on Desmos for one that would match all the criteria. So first you have to do the x ints, and we find that there's no solutions because b squared minus 4ac equals a negative answer. We then find our y int by setting x to 0, and then we go for the asymptotes, where the vertical asymptote is just the denominator of our function set to 0, which comes out to plus minus 2, and HA is just the coefficients divided each other, which is just 1, because they're the same degree on numerator and denominator. Now, there's no holes because 0 over 0 is not possible. So we can go on to our first derivative test, where I pretty much just use quotient rule, simplify that down, solve for the x and y using quadratic formula. Then I sub in the x values to find my y values. I run the test using this line right here, where I just subbed in the points, and I found where it's increasing and decreasing. Here I have the intervals. Then I run my second test, and I just use quotient rule again, just doing that right here. And then we run into the issue where when I'm solving for my POY, I can't use quadratic formula and I can't factor. So I use Newton's method, and I see from the graph that it should be around -7 as my POY, and I can confirm this just by graphing this function, and it's around -7, so that's my first guess. I find f prime of x and f at x, and I just run it. I go f at x over f prime of x, and then added our original guess. We find the first iteration, then we do the same thing. We find our second iteration, so we find our POY. We sub that into our original function. We get the POY is -7.6 and 0.66, right? So now we're done all the steps. We have to graph it and then dance. I'll do that after I'm done this video. But first, let's just look at my graph. So right here, we have my graph, and we have, just take a good look at it. I have all my points set up, all my points, my max, my min, my POY, my y-intercept, and I have my asymptotes. I graphed it like this, and now we can look at my Desmos sketch, and we can see that it's pretty much the exact same sketch, right? And you can see right here, we have all the key points that I have, and it looks the same. And right here, when I was graphing this, I saw that around -7, we would have a POY, and that's why -7 was my first guess for my POY, because I noticed this is concave down, and this is concave up. So there's some POY around here. We can confirm my derivatives on derivativecalculator.net right here, where we do my derivatives. We get the exact same derivative as my derivative that I calculated right here. Yeah, it's the exact same. And then we have the second derivative where I did, and over here we have my derivative, and then I have my second derivative on derivativecalculator.net, and as you can see, they are the same. They just factored out an 8. So, and then to prove my POY, we're going to go to Symbolab, and we're going to see right here my function, and we're just going to quickly scroll down and see that right here, it found that it was -7.63, which is what I got. And oh, look here, it even gives us a concavity table, which we can confirm is the correct one, because we found that it was a concave up in between -7.6 and -2, and it was concave up also from 2 to like infinity, and then it's concave down in the right intervals, right? So yeah, so essentially that's just my work proven, and we're coming right into 5 minutes, just quickly wrapping things up. This is the graph, And this is my graph. We found that it was concave down, coming up to the POI at negative 7.6, right here. Yup. And then it's concave up, and it goes here, finds a minimum, and then it's increasing. Then it's concave down, comes over here, reaches its max, then decreases, also concave down, and then over here, concave up and decreasing, which is everything that we found. So that's 5 minutes, 30 seconds, and I'm done my video. So thank you so much for watching.